Today's defense news, the highlights. India unveils 23,000 crore rupees electronic components manufacturing scheme to boost domestic production. ISRO successfully conducted a short duration hot test of semi-cryogenic engine. Indian Air Force prepares for massive 114 MRFA tender while urgently weighing 40 more Rafales to bridge the immediate capability gaps. Indian Air Force urges full funding and private partnership for HAL's collaborative combat aircraft aims to bridge the capability gaps left by retiring MiGs. Air Power Dynamics, a comparative analysis of India and Pakistan's defense frameworks. NTPC Green Energy signs MOU with Honeywell UOP to explore sustainable aviation fuel production. Veda Aeronautics begins delivery of Sureshastra Mark I to Indian Air Force. In the global highlights, Platview Technologies named platinum partner for Thales and Imperva. NASAMS downs 11 Russian cruise missiles in less than 2 minutes, according to Ukraine's Air Force. Firehawk Aerospace eyes distributed network for 3D printed rocket fuel. A look at the news in detail. Indian government has issued detailed guidelines for the 23,000 crore rupees electronic components manufacturing scheme, the ECMS, aimed at significantly raising domestic value addition in electronic manufacturing over the next 6 years. Firms showcasing strong indigenous design capabilities and adhering to Six Sigma quality standards will be prioritized. Companies lacking in-house design teams risk being left out of the phenomenal change set to reshape India's electronic landscape. Applications will be accepted via an online portal starting 1st May 25. The ECMS targets 59,350 crore rupees in new investments, creation of 91,600 direct jobs, and an estimated 4,56,000 crore worth of production. Incentives will be provided based on turnover and capital expenditure, depending on the category of components produced. Employment generation will also be linked to these incentives. Eligible products under the scheme include sub-assemblies such as display and camera modules, core components like multi-layer PCBs and lithium-ion cells, as well as specific bare components and critical supply chain equipment. Applications timelines vary: 3 months for sub-assemblies and bare components, and 2 years for supply chain infrastructure and capital equipment categories. The scheme lays out specific investment thresholds by component type, offering turnover-linked incentives for investments ranging from 50 crore rupees to 500 crore rupees, alongside additional capital expenditure support for selected categories. ISRO has successfully conducted a short duration hot test of the semi-cryogenic engine at its facility in the ISRO Propulsion Complex, Mahendragiri. This ignition test is the second milestone after the successful first hot test on 28th of March 25. That was a major breakthrough in the testing of the semi-cryogenic engine test program. In this test, the engine power head test article, encompassing all engine systems except the thrust chamber, was subjected to a hot test for a duration of 3.5 seconds that validated the engine startup sequence. During the test, the engine was successfully ignited and operated up to 60% of its rated power level, demonstrating stable and controlled performance. These tests are part of a planned series of evaluations designed to validate the design integrity and performance of critical subsystems, including the low pressure and high pressure turbopumps, pre-burner, and associated control systems. The results provided crucial data to finalize the operational sequencing of the full semi-cryogenic engine. Indian Air Force is advocating for full government funding and private sector collaboration to accelerate the development of Hindustan Aeronautics Collaborative Combat Aircraft Program. This initiative aims to address the capability gaps left by the retirement of the older aircraft, particularly the MiG-21s, which are being phased out by 2025. The CCA program focuses on integrating autonomous drones, often referred to as the loyal wingmen, with manned fighter jets like the Su-30 MKI and the upcoming AMCA. These drones are designed for high-risk missions such as surveillance and strikes along sensitive borders. CCAs are estimated to cost between $15 to $20 million per unit, which is roughly one quarter the price of the advanced manned fighters like the Rafale. The IAF envisions deploying a fleet of 200 to 300 autonomous drones to complement its existing and future manned fighters such as the Su-30 MKI and the AMCA. Now let's study a comparison of the air power dynamics of India and Pakistan. India's air defense strategy combines long-range systems such as the S-400 with indigenous solutions to create a comprehensive, multi-layered shield. Conversely, Pakistan's approach is more tactical, heavily reliant on Chinese imports. India's system surpasses Pakistan's not only in range but also in operational flexibility and technological innovation. India's multi-layered strategy provides a strategic edge by addressing diverse threats and bolstering defense autonomy. Pakistan's systems, although improving, remain largely focused on regional scenarios. Both countries maintain robust air defense systems that reflect their strategic priorities and regional security concerns. Now let's see a comparative assessment of both the systems. In India, the S-400 Triumph, acquired from Russia, has a range of 400 kilometers and can engage multiple targets including aircraft, cruise missiles and ballistic missiles. It offers India a significant strategic advantage. The Barak-8, a joint Indo-Israeli system with a range of 70 to 100 kilometers, designed for both the Air Force and the Navy. It is effective against subsonic cruise missiles. Akash, an indigenously developed medium-range system with variants such as Akash NG extending its range up to 70 kilometers. Spider, a short-range system with a range of 15 to 35 kilometers utilizing Python 5 and Derby missiles. QR-SAM, a quick reaction system with a range of 25 to 30 kilometers, providing 360-degree coverage. Now let's see the Pakistan's air defense systems. HQ-9P, a Chinese system with a range of 125 kilometers capable of engaging aircraft and missiles. LY-80, another Chinese system with a range of 40 kilometers offering medium-range defense. Nasr HATF-9, a short-range ballistic missile with tactical nuclear capabilities intended for battlefield use. What are the key differences? In range and capability, India's systems like the S-400 feature longer ranges and multi-layered defenses, while Pakistan's systems are limited in range but progressing. In indigenous development, India emphasizes the self-reliance evidenced by the domestically developed systems like the Akash and QR-SAM. Strategic depth. India's air defense is designed to counter threats from both Pakistan and China, while Pakistan's systems are primarily focused on India. India's layered approach provides a comprehensive shield against a wide spectrum of threats, while Pakistan's systems are tailored for specific scenarios. NTPC Green Energy Limited has signed a memorandum of understanding with Honeywell UOP India to explore the production of sustainable aviation fuel SAF. The companies will carry out the project by conducting feasibility study that leverages Honeywell's proprietary e-fining technology and carbon dioxide emissions captured from NTPC's power plants and green hydrogen. This MOU aims to collaborate on sustainable aviation fuel production, which is a significant component of NTPC's green energy ambitious green hydrogen hub in Pudimadaka, Andhra Pradesh. The collaboration combines Honeywell UOP's expertise in sustainable aviation fuel production with NTPC's endeavors in developing green hydrogen products. SAF production is a key component of the green hydrogen hub that NTPC Green is developing. The hub spans approximately 1,200 acres and is designed to serve as an integrated hub for green chemicals and sustainable manufacturing. Veda Aeronautics, a Noida-based defense startup, has commenced the delivery of its indigenously developed Sureshastra Mark 1 to the Air Force. Sureshastra Mark 1 is a jet-powered fixed-wing swarm drone designed for precision strikes and tactical operations. Its range over 150 kilometers, enabling deep strike capabilities. Its swarm functionality allows coordinated attacks with multiple drones, overwhelming enemy defenses. Its design, a 3.5-meter length, 3-meter wingspan, and a weight of 90 kilograms, making it compact yet powerful. Air Force awarded Veda Aeronautics a 300 crore rupee contract in 2023 for 200 units of this Smart Unmanned Munition System SUMS. The drone's development was inspired by global platforms like Iran's Shahed 136 and Russia's Geran 2, but tailored to meet India's specific needs. Its jet propulsion system is a rarity among Indian drones, offering high-speed precision attacks. The Sureshastra Mark 1 is expected to enhance the Air Force's operational capabilities, particularly in high-risk missions along sensitive borders. Now, some global news and some news from the war zone. Platview Technologies, a leading provider of ICT and cybersecurity solutions, has been appointed a platinum partner for Thales and Imperva in Africa. As a platinum partner, Platview Technologies gains access to Thales and Imperva's world-class cybersecurity technologies, further enhancing its ability to secure critical applications, protect sensitive data, and mitigate risk for enterprises in key industries. From the war zone, Ukraine forces operating NASAMS air defense systems downed 11 Russian cruise missiles in less than 2 minutes during a mass aerial attack. The US Norwegian made National Advanced Surface to Air Missile System have been in service with Ukraine forces since November 22 when the US delivered the first batteries and amid escalating Russian airstrikes. The NASAM system, which has a maximum range of 50 kilometers depending on the model used, is particularly valuable for Ukraine as it uses the AIM-120 AMRAAM interceptor missile, which is the same missile used in air-to-air function in Western fighter jets. Firehawk Aerospace, headquartered in Edison, Texas, is revolutionizing the rocket motor industry with its innovative approach to 3D printed rocket fuel. The company uses thermoplastic materials to rapidly produce rocket propellant in just 3 to 6 hours compared to traditional methods that take 15 to 60 days. This process involves a hybrid engine design that combines solid and liquid fuels, offering unique capabilities like controlled burns and enhanced safety. Firehawk's distributed network for 3D printed rocket fuel aims to streamline production and improve accessibility for various applications, including missile interception system and second stage boosters. The technology also protects critical components like ammonium perchlorate from reacting during the printing process, ensuring stability and reliability. This advancement not only reduces manufacturing time but also opens up new possibilities for customized thrust characteristics and safer transportation of rocket fuel. That's all the news for today. We hope you enjoyed the news. Please do subscribe to our channel and do give us your feedback. Thank you and have a great week ahead.